Hello everyone and welcome back to my channel. My name is Piyush. This is video number 50, yes, 50 in CK 2025 series. And in this video, we'll be looking into operators in Kubernetes. Yes, operators from the theory perspective, from the demo perspective, we'll do the operator installation, we'll see all the components involved, the entire flow end to end and everything, right? So let me just share my screen and I can just walk you through what we'll be covering in this video. So we'll start with like explaining what exactly is an operator in Kubernetes by defining the difference between traditional and operator pattern. Okay, so how it works traditionally, the deployment and management of any application in Kubernetes versus how it works with the operator, and then how operator works, the key components involved in the operator, and why do we use operator, like what benefits that it comes with uh, when we compare it with the traditional approach. Then we'll do the operator example installation, and the demo will be with the help of cert-manager. We'll be doing the entire setup end to end. Okay, so let's try to understand the difference between manual and automated or operator pattern in Kubernetes. Okay. So let's say you are performing a traditional deployment in Kubernetes without using any tool, without using any third-party application. Okay, just the native Kubernetes installation. Okay, so let's say you are a user, a DevOps engineer, a Kubernetes administrator, or someone who tries to deploy an app as a pod or as a deployment in Kubernetes. Okay, so you deploy it by defining a YAML file, a manifest, or using Helm installation, customized installation, or any other way. And you do the configuration as well by yourself. Now, all the updates that you have to make, you have to do it manually. Okay, so you are responsible for making sure your application is up to date with the latest images, with the vulnerability patches, and all the latest all the latest code as well, right? And then if you are not using any tool for the scaling like HPA, VPA, KEDA, or any other tool, then you are responsible for manually scaling the application when it needs. And yes, of course, like scaling, you have to perform the rollback as well whenever you want to, or whenever there is an issue with the existing version, right? So this is the manual approach or the traditional way of deploying and managing your application. Now, how do you do that with operator? Okay, so as a DevOps engineer, you deploy the operator. You don't deploy the application directly, you deploy the operator. You define the desired state in the operator configuration. Like, this is what the operator is all about. This is what I want to do with the operator. This is what I want my operator to do. And then operator is responsible for performing the configuration changes, the deployment, and all other aspects like scaling, updates, rollback, everything that was manual over here. Right now it will be done by operator in the operator pattern. It is all automated. So operator can be viewed as a DevOps engineer that you have hired, and that person will be responsible for performing all those duty, but automatically. And you don't have to make a person sit 24 by 7 whenever there is a need of manual scaling or rollback or any updates to be made in the application, right? So you do that with the help of operator. So it simplifies the entire development life cycle for you. Like, yes, you can use any CI/CD tool, a GitOps tool with the manual approach, but then there is a lot of maintenance, there is a lot of work that needs to be done for that. Operator is pretty simple, and you can do the operator installation using just a few commands. We'll look at that, and it is easier to manage. Plus, you can create separate operator for separate task, and you can keep it isolated. So operators has a lot of benefits over any CI/CD tool or over the traditional approach. Okay, so let's see how it works. So as a user, you um, first, as a DevOps engineer or as a user, you create your operator, you install your operator. Okay, and then you have your custom resources, the custom resource definition, which we have covered in the previous video. So make sure you watch that if you're not aware about these concepts. So custom resource definition will perform the validation based on, sorry, custom resource will perform the validation based on the custom resource definition. And this custom resource is an instance of the CRD. Okay. And whenever a user make any changes in the custom resource, okay, whenever you are changing anything in the custom resource, this operator, because this is continuously watching your custom resource, okay, there is a reconciliation loop that we call it. So it's a loop that's going on, so it's keep on watching your custom resource for any changes, and whenever it detects any changes, it changes that event and adjusts the state in the Kubernetes API. Okay, so it actually makes sure that your desired state should be also and should be always equal to the actual state of the resource. Now you must be thinking, Piyush, how is it different with any GitOps tool? Okay, so with GitOps tool, it makes sure that your code that is there, like your single source of truth from the GitHub repository, that should be your actual environment specific configuration, right? It works on deployment, it works on infrastructure as a code, and so on. But with operator, it actually based on the events. Like how is it different? So for example, which we'll be discussing now, let's say this cert-manager. Okay, so let's have a look at this cert-manager, and then it will be clear to you the difference between any GitOps tool, CI/CD tool, or the operator. So as a user, you deploy your operator, your cert-manager operator. You have deployed it. Then you have created a CR and CRD. Okay, and then based on this CR, you created two custom resources. One is issuer and one is certificate. Okay, issuer who will be issuing the certificates, and the actual certificate resource. So this operator, okay, it keeps on watching the custom resource. As soon as it find a custom resource, it actually does the following: it issues the certificate, it renews, like automatic renewal of the certificate, and it injects that into the Kubernetes secret. Now this is the desired state. What is the desired state? That the certificate should be issued, certificate should not expire, that means it should be valid, and the secrets should be injected in the Kubernetes API. Okay, so these are all the desired event that it should take. So it keeps on watching the custom resource, like you have a certificate, whether it is expiring or has it expired. If it is expired, it will renew the certificate. If you have created a new certificate, it keeps on watching and it makes sure that the certificate is issued. Certificate is valid, it is issued, and it's not in the expiry state. So that's the main difference. It watches the end state of your resource, how it should be. Like let's say you have created a pod, okay, and you want to make sure that once the pod is in the running state, it waits for a few minutes and then it should be completed. Just an example. Okay, so this operator will keep on watching your resource and keep on checking. Okay, so 10 minutes have been passed and now it should be in the completed state. So if it is not completed, it will change the status to completed, something like that. Okay, so this is the benefits of operator over GitOps tool or any CI/CD tool. Now let's have a look at the key components of an operator. So um, first is CRD, then CR, which is an instance of the CRD, and then we have the controller. So this controller watches the custom resource and reconcile the states. It's make sure that your desired state is equal to the actual state. In case of a certificate manager, the desired state is certificate should be approved, it should be valid, and it should be auto renewed. So this particular cert manager operator will make sure that this desired state should be the actual states of all the certificates that has been created in the cluster where the operator is running. Okay, now you might have already understood now by now like why do we use operators? First is to automate tasks. Okay, so we are automatic all the manual tasks, we are making it automated. Then to take care of all the day two operations. What are day two operations? So operations such as backup, restore, updates, scaling, all these tasks. For this you have to create a separate tool, a separate maybe a separate CI/CD tool, a separate observability tool, or separate scaling tool. These all can be done using the operator, the one that you have created. Okay, so and we have looked into the cert-manager operator. So now when it comes to operator installation, there are different ways. So one is kubectl tool, by installing the operator YAML. Then we have Helm charts available for each of the operators. And then we have OLM. OLM is the Operator Lifecycle Manager, using which we can install any available operator from the catalog. We can create our own operator as well, but we can also install the existing operators from the catalog, which is publicly available. For example, cert-manager, Prometheus, Argo CD. These all are the operators that is available on the um, operator catalog, and this operator catalog is called Operator Hub. Okay, so operatorhub.io, from where you can check it. I'll show you that. So this is nothing but an online repository or online registry for operators. Like we have Docker Hub for your Docker images, right? We have artifact registry. We have several other repositories for different purpose. Similarly, we have Operator Hub for operators specifically. Okay, so you actually install OLM, and then using OLM you can install any operator from the Operator Hub. It's pretty simple and straightforward. I will show you that. Now you can also write your own operators. You can install it publicly available operator, but you can also install your own operator, and you can use that. You can use Helm, you can use Ansible, or you can use a Go based operator written in Golang. Okay, so Golang or Go based operator is the preferred way of writing your own operators, but you can choose any of these. All right, let's do the certificate manager operator installation. So I have logged into my free playground of Code Cloud. You can find the link in the description. It's free to use, so make use of it, or you can use your own playground, or if you have any own Kubernetes installation, feel free to use whatever you have. Okay, so um, before that, I want to walk you through the Operator Hub. So this is the Operator Hub. Like this is a repository for all the community operators, all the paid operators, and everything is there. So different providers have different operators, and it's based on different categories, based on different providers and their capability level. But you can search over here. There are very popular operators such as Prometheus. Okay, so you can find Prometheus over here. If you search, you can see Prometheus operator over here. Then we have Argo CD, which is over here. Then we have plus certificate manager, the one that we'll be using. So once you find it, click over there and click on install. So you will find the instructions over here, or you can follow the GitHub repository as well, because these instructions will just install the cert-manager operator, but it will not have further instruction of how to use it. Right, you have to figure out yourself, or you can read the documentation. You have to create all these resources, but I have created a simplified guide over here in the GitHub repository. Is the same um, GitHub repository that I have been using for this series. I have created a separate folder for day 50, and the name is day 50 hyphen operators. You will find it the description. So we'll start with installing OLM. So OLM is the package manager for operators. Okay, this is as simplified as it gets. So using this, so you install your operator, and then you provide instructions to your OLM that install this operator from the catalog. Okay, so this first step will install OLM. Okay, so I'm gonna run this command over here in my playground. So it should take a few minutes. It will install all the respective CRDs. It will install all the respective, it will create some namespaces, custom rules, bindings, and many other resources you will see in the on the screen, like network policies, service accounts, and so on. Once it is done, this command will be completed. Currently it says waiting for the deployment olm operator rollout to finish. Okay, so it has the logic to watch for the resources, and once the resources are up, once the pod are healthy, only then this command will be completed. So this is how olm will be installed. Okay, it says install ready and deployment. So there are few deployments, as you can see: olm operator, catalog operator, and there should be one more, I believe. All these deployments will be created and the pods will become healthy after this phase. So once that is done, you can install the operator using this command. Okay, it's basically a YAML. In this YAML there is an instruction of which operator you need to install from the catalog hub. So it has the namespace details, it has the name of the certificate manager. If you want, you can open this file in a new tab and view the content, but it's a simple file. I'm sure you will be able to figure it out. For now, I can just run this, and it says subscription operator core OS my cert manager has been created. So it created a CRD, I believe. Okay, and now you can wait for olm pods to be ready. So run this command get pods on the olm namespace, and as you can see, there are few, because there were one, two, three. There were like four deployments. One was catalog operator, olm operator, operator hub io. Why the session is killed? Let's wait if it's reconnecting or not. Okay, let me run the command again. It will take a few more minutes. Okay, let me pause and do the steps that I have done till now. Okay. Okay, so I have done the operator installation again, and now let's run the get pods command on olm namespace. Okay, so all these pods are up and healthy. Then, as part of the next step, there is get csv hyphen and operators. So there are certain other CRDs that will be installed in the operator namespace when we ran this command, but it's gonna take a few minutes. So I'll just put a watch over here so that we can see once they are up. Okay, so once they are up, you will see the status from installing to, oh, it's over there. So you will see the status from pending to installing to succeed. Okay, so I'm just gonna pause the recording till it's doing its work. Okay, so after a few minutes, as you can see, the status changed from blank to pending, then it became install ready, then installing, and then finally succeeded. Okay, so the CRDs has been installed successfully, and you will see the cert-manager version 15.5 has been installed. So the so this was the default version, I believe, but it installed the latest version, 16.5. Okay, so I'm just cancel this command, and now you can do kubectl get pods on the same namespace, which is operators, and you will see some pods as well. So these pods, cert manager, ca injector, search manager, webhook, these pods are now managed by the cert manager, right? So cert manager operator created and these pods, and it will be watching these pods, which will perform all the action, right? So now let's go to the next step. The next step is the verification, which we just did. Okay, and make sure you check the CRDs as well, that cert manager CRDs have been installed or not. So you can just run get CRD and grep for cert manager. You will see different CRDs for certificate request, for acme install challenges, issuers, orders, and so on, right? These are different CRDs that are part of the bundle. Now create an operator group. So operator group defines a set of namespaces that operator will watch. Okay, so in this YAML, as you can see, this will create an operator group in the operator namespace with this name, and it will watch operators namespace. You can have multiple namespaces. It's a list inside the target namespace. Okay, so for now I'm just gonna copy this YAML, operator group dot YAML. I mean, give it any name you want, and then kubectl apply hyphen f og.yaml. Okay, so it says created. Now run the command get issuer and get certificate. So these are two custom resources, but we have not created the custom resources yet. We have only created the custom resource definitions. So if you run these commands now, you won't see anything, right? Because we have only created the definition. So let's create the resources. Now issuer, why do we need issuer? Because we are giving a certificate management authority the permission to issue a certificate for us, right? So now in this case we are using self-signed certificate. That means we'll be signing it by ourselves. The digital signature will be self-signed, so we need to create a self-signed issuer. Okay, so over here in the spec we need to provide self-signed, and like the API version is cert-manager, kind is issuer. Okay, so I'm gonna copy this and create the YAML for issuer. So vi issuer dot YAML. Okay, paste the YAML and then apply hyphen f issuer. Okay, now this is a custom resource of kind issuer. So kubectl get issuer in the default namespace. So that's why now it says self-signed issuer equal to true. Now we have created the issuer. Now we need to create a certificate that this issuer will be issuing, right? So here is the YAML for the certificate. Okay, now vi, and let's call it cert.yaml. And in this, what we have is, as you can see, it will create a secret with this name. Okay, and then DNS name is this. So we are telling the certificate authority to issue a self-signed certificate for this domain. Okay, and using the issuer this. So this is the issuer reference we are passing. So now kubectl apply hyphen f cert. Okay, now do get issuer again. The status is true. Now if you do get certificate, okay, the status is true, and it has created a new secret as well. So if you do kubectl get secret, you will see a new secret has been created just now. This secret was created for the certificate management, and if you want to describe this, describe secret, and secret name is my app TLS. It has three fields. It has CS cert, TLS cert, and TLS key. So it created the cert, it signed the certificate, and it generated the key and certificates and created as a secret in the Kubernetes itself. Okay, so that's what it did. The status, as you can see, of the certificate is ready equal to true. That means it has been issued. So let's go over here and secret, describe secret, and yeah, you can check the logs as well. So this will check the operator logs, and we will see the status in real time. Okay, so run this command, and over here you will see, let's see where it is. Okay, over here found status change for certificate, my app certificate condition ready from false to true. That means the certificate was created. It was initially in the false state, but then because operator is watching it, operator checked the desired state, which is it should be true. The certificate should be issued. So it did it work, and it updated the status from false to true. So it has issued the certificate, and that's what we wanted to test, right? You can follow along, you can check the pods and everything over here, and then finally you can do the cleanup. But this is pretty much basically what the operator did for us. So I hope you were able to understand like how operator works and what we did in this case, especially in case of certificate manager, how it how we installed the olm, how we install operator using olm, and then it issued the certificate for the newly created certificate and the self-signed issuer. So try it out yourself and let me know in the comment if you face any issues. But then I have also created the GitHub repository with the step by step instructions so you can follow along. So yeah, thank you so much for watching. I will see you soon with the next video, and till then, happy learning. Take care.